Hi guys, today we're going to graph radicals. Here is the equation. It's going to look just like graphing quadratics in vertex form. Okay, so you have your radical. The A is still going to be your multiplier. It's going to stretch it up and down. Okay, H and K are still going to translate it, move it left and right, up and down. H, you're still going to do the opposite. He is a liar. K is going to tell the truth. He is going to put it up and down. Now, quadratics, we graphed the vertex first, then we plugged it into our calculator and moved it. I'm going to show you how to graph these without having to use your calculator. Okay, there's going to be 3 steps. The first step is going to be to graph the parent function. Okay, I will talk about the parent function here in just a second. Next, we're going to do the amplitude. Okay, that is your A. So you're going to multiply y values by A. Multiply your y values by A. Then we are going to translate. Okay, so let's talk about the first step. All right, on the first step, it's going to be just like we did with the other ones. We're going to graph the parent function. So every single time you see these, we're going to graph the parent function. All right. Now remember, parent function is just this: y equals radical x. Okay. And so think about this. I can never have a negative inside the radical. It's an imaginary number. So smallest number I can put in there is 0. Well, you plug a 0 in there, and what do you get? 0. So we're making almost an input-output table. So my first dot will always be at 0, 0. Next, all right, what's square root of 1? 1. So my next dot will be at 1, 1. Okay? Then I start thinking, okay, what number has an even output if I plug it in as an input? So next thing would be 4. Square root of 4, 2. So I come over to 4, go up to 2. There are my 3 parent dots. Okay, you will always start with these 3 parent dots no matter what. So let's do an actual example. Let's do number 1 on your paper. Number 1 is 2 radical x minus 5. Just like that. Okay, so we said I'm going to start with these 3 dots no matter what. Next thing I do is I go with your A. The A is 2. So I'm going to go through here and I'm going to multiply each y value by 2. What's 0 times 2? 0. That dot stays there. Then I come here. What's 1 times 2? Well, that's 2. So I erase this dot, and I move it up to 1, 2. I come here. What's 2 times 2? 4. So I erase this dot at 4, 2, and I now make it at 4, 4. So there's my new dots. I've done step 1. Step 1 was to graph the parent function. I've done step 2. That's to do the amplitude. My third step now is to translate it. Now look, this negative 5 here, it is outside the radical. So that means it's a K. K's move up and down, they tell the truth. So we're going to move each dot down 5 units. Okay, so I come to 0, 0, 1, 2, 3, 4, 5. There's my new dot. You can X them out, you can erase them, it doesn't really matter, as long as you know that they're not part of the graph. I take this one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are my new dots. Now, last thing we do, draw a line through it. Okay, so I come here at this dot. This is a ray. It's not going to extend this way, so I come at this dot, and I extend to the right, and I draw my line. Okay? So that's how you're going to do it. That's how it's always going to be on these. Remember, if you have a negative A, it's now going to look like that. It's going to flip it, and it's going to be going down. You'll never have a ray that faces this way. They always will move left to right on graphing radicals. Okay? All right. Good luck.